Morning, everyone.
Good morning. Thanks for coming.
Hopefully everyone enjoyed the keynote. We are here to present how serverless helps you build highly scalable and secure apps. So I'm joined on stage by Myles Borins. He's a developer advocate on Google Cloud Platform, and he is also a member of the Node.js Technical Steering Committee, and he also triages all of the bugs that come in about Node. So if you're filing bugs about Node, he is the man determining if they are serious or otherwise.
Hopefully right.
Hopefully right.
This is Michael Mcdonald, a product manager here at Google. Done work on Firebase and GCP. A lot of our recent security products were things that Michael was working on. We're really excited to talk to you today all about doing serverless on cloud and how some of the products that Michael's been working on and some of our partners have been working on will help you write secure applications.
Cool. So how many people feel like they're security experts? Anyone want to raise your hand? A couple people? Yeah, I don't even feel this way. So we're going to actually start kind of from foundations and talk about what is a threat environment and go over common vulnerabilities or common threats that your app may face. So hopefully you'll walk out of this. If you're not feeling like you're an expert at the end of it, hopefully you'll feel at least a little more confident. We'll also be talking about, in the kind of traditional world, what those threats look like and how they translate into a serverless world. Serverless does a lot of things automatically, but there are still some things that you're going to have to do. And lastly, we'll also talk about how Google Cloud, and in particular Google Cloud serverless offerings, make a lot of that easy. And in the places that we don't automatically do for you, we have some partners and other vendors that will come up on stage and demonstrate how their tools can help make your apps more secure. As a bit of a high-level overview, a couple things. One, we have the camera emoji. That means pull out your phone and take a picture, or otherwise make a mental note of it. But the first important link that we're going to be sharing is NodeSec Roadmap. So if you go to this link, it has a ton of different threats. A lot of them are kind of specific or kind of in the context of Node.js, but the threats themselves are general and can apply to whatever language or environment you're running in. So we're going to be using Node. We obviously have some pretty deep technical expertise there, but it should apply to whatever language you're working in.
So we just used the term threat environment, and you're probably wondering, what is a threat environment? Here's a definition from software engineer Mike Samuel. He's actually the engineer who put together the NodeSec roadmap that we just showed. A threat environment is a set of targets under attack and the tools that might be used to get at them. It's important to know that different targets are vulnerable to different tools in different ways. So an application running on one type of provider is going to be vulnerable to different types of tools than an application running in another environment. If you're running an application in a virtual machine that you are maintaining yourself on your own silicon, there's a different threat environment than if you're running something on App Engine. And knowing that threat environment helps you know what tools you need to have to protect yourself from attack. So we're going to talk about a couple different threats today. Quickly listing them off, we're going to talk about 0 days, malicious and low-quality code, remote code execution, denial of service, classically referred to as a DOS. We'll talk about leaked credentials. We'll talk about data exfiltration, query injection, and one of my favorites, which doesn't always make these lists, poor developer experience. And we'll dig into that in a bit.
Cool. So we decided that the best way of showing common vulnerabilities is to build a really terrible app and show it to you. So Myles went on vacation over this past weekend, and I was hounding him ceaselessly on Friday afternoon to build an application for our demo. And he, of course, just wants to go on vacation. So he actually builds the app on the way back from Tahoe. So it's like a 3-4 hour drive. He hacked together a bunch of functions to build a content management solution. And obviously, any code written in the back of a car is bound to be absolutely horrific, right? So he has a save markdown function. By the way, if no one is familiar with it, we're using Cloud Functions. So Cloud Functions is Google Cloud Platform's functions as a service offering, which is kind of the prototypical serverless offering. And so he wrote a function that takes in Markdown, converts it to HTML, and writes it to Cloud SQL. And then we have another function that can serve that HTML from Cloud SQL. We're actually even just going to focus on that first function, because trust me, there are a lot of things wrong with it.
So this is fun. You might think that we're just making a fun joke, but I legitimately wrote this in the car on the way home from Tahoe. And before we dive into the code, I'm just going to show you that this is live and actually works. This is the payload that we're sending. It's right in the body, like any good post request should do. The author is my name. The title, oh my God, the hacksters are at it again, and the markdown drop tables lol. We're going to go and post that, and we're going to have a response from the database, because your raw database response is what you should always be returning. And we could see that this works. So let's take a look at the source really quickly. You could see that we're promisifying stuff because we're using Node 8, which we just announced yesterday, which means we can use async await, which I absolutely adore. We have all of our credentials in line, so we never have to look at that piece of paper that I have on my desk. We immediately create a connection to the pool. We're doing this with creating a pool for the MySQL direct connection, so that it will be able to pool resources when we have multiple functions go up and be able to reconnect if we have any connection issues. This is also another feature that we just announced. You can do direct connect from Cloud Functions now. In the make post async function here, we're going to convert the markdown that's been sent to us into HTML. We're going to make a new date object. We're going to post directly in. You can see all the information that we're doing in line here. Nice and sanitized or not. Then we're going to promise returning it. And we just do a little try catch here where we await the result of make post. And then we respond with the results themselves. Back to the slides.
Yeah, there are definitely some issues with that.
Yeah.
So the first thing that we're going to talk about, right, if we were completely unaware of these vulnerabilities, we might run into something called a 0 day. So how many people are familiar with 0 days? A couple people? OK, half the room. So normally when you have a threat, you have this thing called the window of vulnerability. So it's kind of from the time that the vulnerability is disclosed. Ideally, someone sends the email to security@yourcompany.com and says, hey, I think there's an issue. Hopefully, they're not selling it on the internet to someone else who's going to go and exploit that. But ideally, in the best case, you, the vendor, get that information. You tell your engineers, or you go and patch that vulnerability yourself. And ideally, you can actually patch the vulnerability and get users to apply it before any exploit is actually found or used. But if the exploit is active before things are fixed, you have this kind of window of vulnerability, your kind of danger zone of when users are likely to encounter it. In a 0 day, that's entirely flipped, right? The whole premise of a 0 day is the exploit is actually active and out in the wild before anyone knows about it. Or you become immediately aware on day 0 that there's a problem. And then you have to scramble to go and fix all of your code and hopefully get users to update it. So how do you stay ahead of what 0 days potentially exist to avoid those?
So acronyms. We're at a Google conference, so we have lots of acronyms for you. CVE, CNA, CWE. So the first one, CVE, the Common Vulnerability and Exposures. This is a enumerated list that you can get from MITRE. Every single CVE is a number that you can go and look up. It will give you the name of the dependency or project that has a vulnerability and what that vulnerability is. With a CVE number, we're able to know what's going on. If you're running a certain project like Node in production, for example, you can cross-reference against known CVEs and know if the version that you're using is vulnerable or not and what vulnerabilities you're vulnerable to. You have a CNA, which is a CVE numbering authority. This is who assigns a CVE number to a vulnerability. In the Node project, for example, we actually get pre-assigned blocks of CVEs from MITRE directly and act as our own CNA, associating CVE numbers with vulnerabilities as we discover them. Before we became a CNA, we were actually using MITRE directly as the CNA. So every time a new vulnerability was about to be disclosed, we would write MITRE with that information, and then they would get back to us with a number. This actually resulted in times where we would have to put the patch out before we had the number and update with the number later, which is why we went through the process of becoming a CNA. The third one that we have there, CWE, a common weakness enumeration. CWEs are a list of numbers that you can use to reference certain types of vulnerabilities and known patterns that are problematic. So if you are a security researcher, you may use a CWE when reporting. So for example, using all these in a sentence, an open source project can use the MITRE CNA to issue a CVE for a patched vulnerability. When a security researcher reports a vulnerability, they may include a relevant CWE.
Awesome. Thanks, Myles.
These links up here go to CVE and CWE, which are both on mitre.org. So you can go through and look at what CVEs are out there, what you have to worry about. And if you're thinking about reporting things, you can go to the CWE to include a CWE with your report to a project when you're reporting a vulnerability. So vulnerabilities go all the way down the stack. When we start off and think about it, you have your hardware. I'm not going to talk about some of those hardware vulnerabilities that happened recently because they caused me existential dread. So we're going to move up the stack. And that moves to the operating system. These can be vulnerabilities in things like in Linux. It could be in POSIX itself. We had a really fun one back in the day with RealPath 3 in Node. Find me later. I'll tell you about that one. We move up the stack, and we move to our language runtime. This is Node itself. There may be vulnerabilities in Node, such as regular expression DOSes, which we've had in the past and patched fairly recently. You move up the stack, and you're now into your dependencies, everything that you've installed via NPM. We've seen some recently, and we'll dig into vulnerabilities that could affect you via your dependencies. And finally, you reach the top of your stack, you reach your application, and it's possible that you're writing your own vulnerabilities. The thing that's important to see about this all the way down is while you need to be managing your own application code and making sure that your team is writing secure code, there is a lot of stuff underneath you that can be causing you to be vulnerable in a transparent way. You may have no idea. Now, a great thing about running serverless is that everything below your dependencies is managed by us. So if you deploy something to Cloud Functions or you deploy something to App Engine standard, whenever we get notified of new CVEs, whenever new patches are available, we're able to patch the language runtime, the operating system, and even replace the hardware from under you without any downtime or you having to make any changes on your end. When the Node project does a new security release, we are, in a timely manner, updating all of the functions that are already deployed so the next time that it runs, it's not going to be vulnerable. This is one of the advantages to using serverless. So one of the things that we talked about are the dependencies, which is bringing in malicious or low-quality code into your project. So there's lots of ways that this can get in. You can have malicious code. This is code that is explicitly trying to be malicious and do things, like pulling things from pastebin. You can have low-quality dependencies. These are just packages that weren't very well designed and introduce unexpected bugs and performance problems into your code. Regular expression DOSes are some of the most active ones that you'll find here. And also unintended requires. It's possible that you unintentionally require things into your project because of dynamic dependencies. So one of the things that bad dependencies may do, or even may happen in your own code, is remote code execution. How many people in the audience are shipping a val in production?
Or the equivalent in your language.
And you may actually be shipping a val and not even realizing it. If you're using VM run in this context, or any of the VM objects in Node, that actually is still sharing the same context, and you may be leaking and changing your context if you're running unsanitized or unknown code. So remote code execution, an example of this actually happened fairly recently with the eslint security incident. Is anyone familiar with it? So last week, eslint scope module was hijacked to steal npmrc credentials. One of the maintainers of the eslint project had their machine compromised. The person who compromised the machine then published a new version of the eslint scope module as a patch update. Eslint scope module is dependent by eslint, and if any of you write JavaScript, eslint is the most widely used tool for linting code, which is the way that we know that we write errors because dynamic languages are fun. So when this vulnerability happened, the credentials were stolen, malicious code was published. That malicious code was pulling down a pastebin link and then executing it via a val. And at that point, it was then uploading credentials or attempting to upload credentials to a centralized service. This is what's formally known as a worm. It was compromised and then trying to compromise other packages and spread across the ecosystem. There's a couple different ways that we could defend against this. If you were using explicit lock files, you wouldn't have updated to the patch version if you were sticking to the lock file. And if you had two-factor authentication turned on your account, the worm would not be able to spread because when it tried to publish, it would be asking for your credentials. I think this is a really great example of where the inconvenience of 2FA pays off in the not having all of your modules stolen. So this was how the attacker did it. They modified the package JSON in both eslint scope and eslint config, adding a post-install script that ran this lib build.js. And lib build.js called an HTTPS GET on pastebin, got the information and then evaled it. this right here, that line, is why the worm did not spread as wide as it could. Generally, in Node, when you're doing something .on, you want to be concatenating the entire string and then do on-end to evaluate it. What we can tell from this attack, though, is that we had a really sophisticated attacker who just was not well-versed in the Node APIs. So thankfully, this caused a whole bunch of crashes to happen, and then those crashes, when it tried to eval C and C wasn't a full string, it was how people noticed it within 10 minutes. And this is, I think, one of the really great examples of how on top of it the Node community is. Because the second that people knew about it, everyone knew about it, and things were getting locked down. And to come talk about a little bit more about this and some ways of protecting your projects, we have Sergio Silverio, the CTO of NPM. Quick round of applause. Hi, Siege. How are you doing today?
Pretty good. You told me it was a story about a week that I had was not so good, but it's good now.
Thankfully, we talked about it before.
Yeah.
So Siege is going to come up and demo something. Siege is in our Insecure project that we were just showing you, where I brought in a whole bunch of dependencies really quickly. And Siege, what are you going to do for us today?
I'm going to show you how we help you close that gap between when a vulnerability is found, it's been patched, but you're still not in the green zone because you don't know about it, and you haven't applied that patch to your project. So I'm going to demonstrate a really pretty nifty new thing that we've done at NPM to allow you to find out how to do something about this without interrupting your normal workflow. Here I'm in Myles' Insecure project, and I'm just going to run npm install like I always do. Maybe I'm installing a new dependency. Maybe I'm just running install to do development. Oh, holy high severity, Batman. I have a high severity vulnerability that I didn't know about. So now I can find out more information about that if I want. And notice I didn't do anything special to find out. Now I'm going to run a new command for NPM called npm audit. Here, I find that marked, the library I've been using to render my markdown for my app, has a regular expression denial of service. OK, what does that mean? All right, I'm probably vulnerable to it. What should I do to fix it? Well, that's easy too. npm audit fix. Now, the great thing here is if we can give you a patched version of that dependency without violating your Semver requirements that are in your package JSON, we will do it. And we will give you the fix right here with you having to do anything more than just that. Fixed one vulnerability. Now if I run npm install, clean. I'm in that green zone now. I'm safe. I've patched.
That's really awesome. And it was at the...
Yeah.
And can you tell me a little bit more about how it knew that there was a vulnerability?
We have taken the Node Security Project vulnerability database, which is the collective work of the Node ecosystem, which takes this very seriously. And we've integrated that in with npm install. So every time you do a read of packages, we have that security data passed down. Even if you're pulling from your local cache, we can tell you that we found something that you didn't know about last time you ran an install.
That's really amazing. And then we were just talking before about two-factor authentication. I believe NPM has some new stuff coming down the pipeline for it?
Yes, we do. The eslint maintainers, who also had a very bad week, could have done a couple of things to protect themselves from it. They could have turned on two-factor auth for all writes, so that anytime they typed publish for any package they own, they would have to provide a one-time password. We've just rolled out last week, in response to this, a brand new feature where you can protect a package with two-factor auth, so that anytime any maintainer publishes it, whether they've turned on 2FA or not, they have to enable it, provide a one-time password, and install. It is an inconvenience, but if you publish to NPM, please protect your packages. If you are using a very highly popular package, enable this. And this is in the NPM CLI or on our website. You can just flip it on.
Wonderful. Thank you so much, Siege.
You're welcome. Thank you.
Cool. So we saw right there regular expression denial of service. How many people feel like they know what denial of services are? A couple of them?
Mike?
Oh,
Mike?
God, stop.
Mike?
Stop.
Mike?
I don't have time for this.
OK.
There you go. So Myles just exhibited a very classic example of denial of service, right? You have traffic coming in to your application, and malicious traffic then starts bothering you. Maybe it's taking up network resources, or your CPU just hits 100%. You can't do anything anymore. You can't focus on that task that you were supposed to do earlier. But there are also a number of other kinds of denials of service, right? So the resource exhaustion case that we showed there of, say, running out of network or running out of CPU. But you also have a couple of other categories of things that could cause denials of service. The regular expression DOS, for instance, could be kind of a code error issue, where maybe a well-formed request comes in, but it triggers some bug in the code that ends up creating a resource exhaustion, or maybe there's other expensive computation. So for instance, we were doing crypto on the main thread in Node, and basically DOSed ourselves. And then my personal favorite denial of service is an economic denial of service, right? Where someone, one of the great things about serverless is that it scales infinitely. You keep throwing traffic at it, and it keeps scaling, which potentially means that it keeps billing you, right? So if you have budget set or there are quotas in place, those could be throttling you. So we showed the kind of classic denial of service of a resource exhaustion. We'll now show a really fun one, the hug of death of DOSing yourself. So you may have external traffic coming in, and as your cloud functions are scaling up, maybe they're writing to that SQL database, you run out of file descriptors, or there are some other finite resources, and you overload your database, and it falls over. So we have a really cool new tool, so scaling controls. So again, it's really great to have the infinite scalability of functions as a service, but sometimes, because not everything is serverless and amazing under the hood, you want to say limit to only 100 functions can run, because you may only have 100 file descriptors or whatever. There's some limiting resource in the back end. You can deploy your functions with a maxed instances flag and limit it. So once you've done that, your functions will start scaling up, and they'll hit that max instances limit and peter off. So traffic, you'll start providing back pressure up to your clients. Maybe the clients will force retries or do something like that, but your database will be fine. A quick note, so we have a couple of different serverless products within Google Cloud. Functions is kind of the main common one, but we also have App Engine. So App Engine, you're running an application rather than just a single function. It has slightly different scaling behavior. So as your App Engine app is scaling up, it'll hit that max instances limit, but then it will also start routing traffic back to existing apps, because they can continue serving that traffic. So it will still provide that scaling limit, but the behavior will be slightly different. So just something to take into account if you're building an app on App Engine versus functions. And then to prevent the kind of economic denial of service, we can do budget alerts. So you can actually go into your project and say, I want to be notified anytime I hit 50%, 90%, 100%, whatever percent you want of your budget. And my favorite feature of this is that you can actually then trigger cloud functions off of your budget alert. So if you get a budget alert saying that your cloud functions have exceeded 100%, you can trigger more cloud functions. Just a fun little thing. But that is nice, because then you could say trigger a cloud function that would kill an offending process or otherwise shut down resources or deny access. So it's a nice little way of containing that.
So a great way to cause problems for yourself is leaking credentials. If any of you were paying attention earlier, you may have noticed that I leaked all of our database credentials on screen to all of you. Now we're going to be shutting that database down later. But if you had been paying attention, you probably could have made some problems for my demo. But there are common credentials and common ways that you could leak it. Database user and password, as we saw, is a really easy way to leak it. Leaking it by writing it right into your code. That's a great way to say that you accidentally put it into your Git repo, you push it to GitHub. There's bots that are constantly doing static analysis of GitHub to find these kinds of leaked credentials. You could potentially leak OAuth credentials. This could happen by potentially sending credentials in a request, not over HTTPS. Anything that's in any of those hops, if your credentials are in plain text there, they know not only your credentials, but where you were sending them to. You could have credential leaks through improper use of crypto. And you could also, as I was mentioning, publish your credentials accidentally to somewhere like GitHub or NPM. Now, here's an example of putting the credentials right into your code. One of the things that you'll notice about this that is particularly problematic is This MySQL.create pool call, this is a pretty generic way of making this call. This is very statically analyzable. Bots can crawl text. We have BigQuery. BigQuery lets you do this. Like, you can write parsers that will go through and just find this and leak the credentials for you. So one way that we've been thinking about fixing this and worked on fixing this is a great new feature called environment variables, something I'm really excited about. You can now, in the deployment, set environment variables for your cloud functions. You can also set them in the UI when you deploy it. By setting these environment variables, we then, inside of our code, could reference the environment variables rather than referencing the items themselves. And now there's absolutely no way that we're going to be leaking these credentials using our code. Now, this is not foolproof, and we'll dig into that in a minute. But this is a huge step forward. Now, if you didn't want to put it into the environment variables, there's other ways that you could be storing your credentials. We have Cloud KMS, which is cloud-hosted keys. You could use the HashiCorp Vault. We'll be showing some other ways to do it. So you don't need to put it onto your right into the process, into your environment variables. But it is, a really great step that you can take without a lot of engineering investment to make your code more secure right off the bat.
I'm really glad we didn't see anyone get up and run out of the room. Yeah. OK, so we talked a lot about credentials, but there are also a number of things in the kind of authentication realm of what you're doing with those credentials or how you're checking those credentials that can be potentially problematic, especially in a serverless world. So when we started, Myles had a single function, the save markdown function, that went ahead and took the markdown, parsed it to HTML, wrote it to the database. We decided, good code practices, we wanted to split those in two, right? We wanted to have a generic markdown to HTML function, because maybe we want to send our markdown or our HTML somewhere else. And then we also wanted to restrict all that horrific write to the database, passwords and secrets in code into its own little separate function, so that the end, everyone in the end user world is not directly having access to our database. That was awesome, except for the fact that all of these functions are public on the internet. So someone could simply bypass all of our restrictions set up in our markdown to HTML function and write malicious HTML directly into our database. It's called execution flow manipulation. And it's, as we move into a world of microservices or nanoservices, I'm trying to make that catch on, by the way, nanoservices. As we move into that world, these attacks become much more common, especially when you have events. You could imagine an event being triggered from a Google Cloud Storage bucket, going to a function, writing to a database, triggering another event. There are a lot of little attack vectors kind of between those cracks. So one of the new features that we're announcing is security controls between functions. So you can set an IAM policy on a function that lets you control access from not only developers, but other functions or other GCP services. You could have a GCE VM or an App Engine app securely writing to your function, as well as end users who've signed in via Google Sign-In. One of the other things that we're doing is we're starting to make functions private by default. So your functions, your HTTP functions, will no longer be publicly available on the internet the second you deploy them. Your developers can still use the command line to call them, but you don't have to release everything publicly immediately. So we're going to add IAM policies onto both of our functions. The first one, we're going to say all users can take this special invoker role to invoke our first function, our markdown to HTML function. And on the second one, we're actually going to say, we've given a service account to our second function, and we're going to say only our first service account and our first function can invoke the second function. Otherwise, it's closed off from the world. So we have that kind of IAM security barrier between our functions, and that would prevent our malicious content from coming in to the second function. But as I mentioned earlier, we're still making it easier for developers to use it. So if you're logged into the command line, you can deploy your function. It's deployed privately, but you can then just say gcloud functions call and call the function as you normally would. And that will take your developer credentials, pass them through, and let you invoke that function. So if you want to sign up for this, it's in alpha right now. So you can take a photo of that, sign up, and you can start using it shortly. Give everyone a second to take a look at that. OK. Perfect. So there's kind of a parallel to that of not only is there a potential for malicious content to come in, but there's a really high potential for the good content that you have to leave your application. So you could imagine, for instance, instead of a malicious call coming in to your function, you could imagine that someone has maybe done a remote code execution vulnerability in one of your functions and is trying to exfiltrate data. So they're going to take all that markdown content and send it to their own endpoint. The evil.com example down there below. Or you could imagine a similar thing where someone has dumped the process environment variables, which, and this is why we were saying it's maybe not the best idea to store all of your secrets in environment variables. If someone could eval, console log process env and say store that as their name in the database, they could then use our second function to pull all that HTML content out of the database, kind of without you knowing. We're going to actually have one of our partners come up and talk about how to mitigate those threats shortly.
So, joked about this earlier, but query injection is real and alive. So the code that I originally wrote was pretty susceptible. Here's a slightly simplified version of it. What you can see that we're doing that's not so great is we're building the query manually from a string and concatenating information unsanitized that was handed over from the internet. And one of the things that could happen here, which would be kind of bad, is someone who knows how we have it done internally or is guessing could hand us off HTML that internally is actually breaking up the string and including an extra SQL call that is in turn deleting all of our information. And that's no good. We don't want that.
No good.
So we can fix this by escaping. And so one of the things that's really great is MySQL itself, the module for NPM, comes with an escape function. This is not the same as just calling escape on the string in JavaScript. It comes with an escape function that's going to properly escape your data to be put up into MySQL so you can still build the string without worrying about doing it. Now, while this is better, there is best. So we could avoid sanitizing altogether and rely on the library to sanitize it for us. You'll see the set question mark syntax that we're using here. This is taken directly from the MySQL README as the preferred way of posting information. And what you can see that we're doing is we're building an object in JavaScript. We're passing that object over to the MySQL library, and we're allowing MySQL to know how to actually convert everything itself. One of the things that's really nice about this, too, is not only is it going to escape, but it's going to smartly escape. So in the example that I had originally, I was taking a timestamp with a JavaScript date object. You can actually just pass that directly this way, and it will sanitize and turn the date object into the string format that MySQL is expecting. So not only are you removing potential programming errors from a security standpoint, but you're removing programming errors from just a straight up like consistency and correct way of programming. So while the other way of doing it yourself works, like anything in security, if there's a way for you to not do it, don't do it. Let other people who have done it right and made the mistakes before you do it instead. And with that, we're going to bring up Devin Rifkin from Intrinsic. Thanks, big round of applause. So Devin, can you tell us a little bit about Intrinsic?
Sure. So Intrinsic is a runtime enforcement system where basically we want to make it really easy for you to choose exactly which resources your Google Cloud Functions can access. And so when we talk about how to get really good security, you want to talk about least privilege, which is the idea that your function should only be able to do exactly what it needs to do and nothing more. And this is how we're going to protect against some of the issues that Mike was talking about earlier. So the way that Intrinsic works is we actually sit between the runtime and all of your code. So you've got both application code and dependency code. But what we let you do is we let you put policies on that so that when you try to go to evil.com, it doesn't work. So now we're going to actually look at some improved code, sort of what we've been showing before. So this has some of the fixes. This is the split out one. So this is the first function. And this one takes markdown. And it turns it into HTML, and then it passes it to the second function. So when we think about what privileges does this function need to do, it's not really very much at all. In fact, the only thing it really does is down here, it just posts to this post URL, which is just the second function. So when we think about how we want to restrict this function, we really want it so that the only thing it can possibly do is talk to the second function. So let's look at how we do that with Intrinsic. With Intrinsic, you don't change your code at all. So you keep it the same, and the policies, they apply it to all the code. Even malicious code can't get around the policies. So we've got just a single policy here, where what we do is we say, hey, we want to allow posting to this particular URL, which corresponds to our second function. So let's go ahead and look at what some malicious code might look like. So this is a little bit of a contrived example. We're just putting in something that changes the URL into evil.com. But any of the dependencies could do that, or if you had a remote code execution vulnerability, they could easily exfiltrate the data. So let's actually run this function. So we're going to do a malicious call. And this just uses the gcloud functions call. And now what's funny here is it says error, but that's actually good. That's a good indication that we're protected, but let's take a look at the logs to make sure that that's true. So here are the logs, and let me make this a little bit bigger. So we see that we tried to post to evil.com, and Intrinsic blocked this. So it said, hey, this is a policy violation. You tried to post to evil.com, and that's not in the whitelist. So all the intrinsic policies, because we really want to focus on the principle of least privilege, it's just all whitelist-based. You don't want to say things you can't do. You only want to say the things you can do. And this fits in super well with how serverless works, where you have lots of what are we saying? Nano services, yeah. Right?
Catching on.
So this is great, and this protects you, and you can set up notifications, alerts in Stackdriver to notify your team that something bad has happened, right? Something totally unexpected. But in the meantime, your data is completely safe. So that's very good. We're going to look at the next function now. So this is the second one. And this one's pretty interesting because we have another piece of sensitive data, which is the database password that Myles leaked several times already. So we've got these environment variables set up, which is pretty good, right? That's pretty good. So let's go ahead and run this, and we're going to log the environment variables. So we'll run this right here. OK, so it inserted it with an ID 90. I got rid of Myles's pass the database results straight through. Don't want to do that. So let's take a look at the logs. Yeah, so kind of as expected, my password's just there. And so while this is a lot better than storing it in your code, because that means it shows up in fewer places, it still could be exfiltrated. Now, luckily, we're using Intrinsic, so you can't just post it to like your own attacker's server. But Mike kind of alluded to this before. There is, if the attacker is super clever and they're trying to really target you, they might just store it in the database and then go to your blog and see the password and then mess with it that way. So they might exfiltrate it another way. So we've been working on ways of preventing, like even leaking it in special ways. And what we've realized is you don't actually need to see the real value in your code. All you're doing is you're passing along the password to the MySQL database. You're not operating on the actual value. So this is a new type of policy that we've introduced called tokenization. And what it does is it takes your real secrets, so your database passwords or API keys or other sensitive user data. You can imagine social security numbers. You don't really need to do math on them. It turns them into dummy tokens when it's running in the untrusted code area, which is where all your code runs. And that means both your code and third-party code never see the actual value. Then on the way out, we check to make sure that you're connecting to the thing that we expect you are. And if you are, we'll translate it to the real value. But your code never, ever sees the real secret, and that means it's impossible for that code to leak it. So let's see what that policy might look like. So it's super easy. Again, we don't change any of our code. And we've got a single tokenization policy here where we say, hey, we've got this environment variable called dbPassword. We want to tokenize it. And then we want to tokenize it. We want to detokenize it only when it goes to MySQL, and only when it matches exactly this user database and socket path. We don't want somebody to try to steal it by making another MySQL server. And then, again, you don't change any code. We've got a single policy. We don't need to make any HTTP calls. So let's go ahead and run this. So we run this, and it's looking pretty good. We do have ID 91, so we're inserting more things. Let's take a look at the logs. And this is great. So instead of the real password, it shows tokenized by Intrinsic. So if an attacker wants to steal that fake password, let them do it. It's fine. And most importantly, it still was able to post to the MySQL database and insert it. So it worked transparently, but kept you safe. And so we're really excited about these tokenization policies because they let you just get rid of whole classes of attacks. And it's really flexible. It's not just environment variables in MySQL databases. The sources might be HTTP responses or the file system or database entries. And it might go to database entries where you want to store things that you never were able to see. And you might detokenize to particular HTTP requests if you're using like API keys, and even responses to users. So let's say that you pull a social security number from the database. Your app code never needs to see it if it's just displaying it to the user. So we're really excited to have people start using these policies. We think it's going to really help protect things. And thanks. That's what I got.
Thank you so much, Devin.
Thanks.
That was really great. So we've kind of gone through a whole class of errors that are mostly solved through programming and engineering. But engineering is not just about code. If you are running a team, if you are thinking about the process of your organization, there's a whole class of vulnerabilities that can come in because developers just don't have time to deal with all of your policies. If all of your different security policies that you have in place make for bad developer experiences, your developers may end up working around that and making things even more vulnerable than you started with. So some examples of poor developer experience include certain kinds of shared environments. Having dev, staging, and prod all use the same database means that all of your different environments have the same restrictions when writing to the database, which may mean that you have to jump through certain hoops. It could also mean
don't.
Or don't, yeah.
Or they don't.
And you can end up with unreviewed code into production. So one thing that you can do is enforce isolation and use a deployment manager to replicate environments to make sure that you're not getting the wrong things in the wrong place or doing the things you don't want. One of the biggest problems that can happen for people is a slower manual tool chain. Having to manually deploy everything, having it be really slow, introduces lots of errors and edge cases. Using things like continuous integration and continuous deployment can really help fix that. There's a really awesome tool called Spinnaker, which runs on top of Kubernetes, that helps you run all this stuff. We also have Cloud Builder as one of our products that you can use for automating the process of Docker. If you go and look at the NodeSec roadmap, some of the stuff in there that I particularly enjoyed was some of the thoughts in how to separate environments and creating different levels of policy for different environments. So for example, your developers can maybe use any module that they want to use while they're in dev. And when they move to staging, your security team can start auditing them and then actually send it back to dev if some of those don't meet the level of quality that's needed to reach production. What this does is kind of flips it. Instead of creating this really strict policy saying, hey, you can't use anything right now, it allows your devs to run really fast, get the things that they need to do done to figure out how to solve the problem. And then once they've figured out those abstractions, like on Node, there's so many different modules available in NPM. So if we used marked, for example, and that DOS wasn't fixed yet, and they're like, oh no, you need another markdown parser, there's 7 other markdown parsers. Our security team can even come up with 3 or 4 examples that we could switch to. But that doesn't stop the velocity of your team. And so instead of creating problems, we're creating work. It's not, hey, you can't do this. It's like, hey, here's another ticket. By changing that story a little bit, we change the way the developers are working, and we stop, instead of breaking velocity, we improve velocity. This moves all the way through your whole process down to how you're handling 2FA. You need to make sure that the process that you have in place has buy-in from your teams and is not hurting velocity. But that doesn't mean that you compromise. And this is a balance that's hard to find. But what we're hoping is with all the different things that we remove by moving you to serverless, that you're able to focus on more laser-focused policies, more laser-focused workflows, and can create a velocity that your team's on board with, and you end up with much more secure apps at the end.